Hi everybody, Mr. Taylor back with Rockin' Math. Just wanted to talk to you briefly about squares and square roots. This will get us set up for the Pythagorean theorem and our measurement portion of the course. A square root is one of two equal factors of a number. For example, the square root of 25 is 5 because 5 times 5, or 5 to the second power, is 25. We also, now let me tell you what this is called. This portion here is called, and that's too neat for me. This portion here is called the principal. It's called a principal root. And the only thing the principal root is the positive. So it's just simply the positive square. Okay, so keep that in mind. So you'll hear me talk about the principal square root. That means the only thing I want is the positive. But be also notice that we do have a negative 5 times a negative 5 will also give us 25. And it is also the square root of 25. And the reason why, because we know that the rules of integers says a negative times a negative equals a positive. So all square roots literally have two squares. One is positive times a positive, and the other one's a negative times a negative. But here we will simply just use the principal root, which is a positive times positive. Okay, I'm going to put that there so you understand. Positive times positive is called the principal root. Okay, the square root of a number is one of its two equal parts. This equal factors. This is the definition. Sometimes it is written as x squared is equal to some number. Then x is actually the square root of y. So x squared is equal to y. So please understand that if I said 5 square and I'm saying that 5 square is equal to y, then of course y is equal to 25. The symbol that they sit under, which is this particular symbol, is called a radical sign, and it's used to indicate a non-negative square root or the principal square root. The square root of 25 indicates that the non-negative square root or the principal square root in this case is 5. Now we also have, or we use this, as you can see that, and I hope that's clear enough for you. But what that is saying that the negative square root or the non-principal square root, the negative square root of 25 is, and you take the square root first, what's inside the radical, it applies just like PEMDAS, and you put the negative on the outside. Okay, now we looked at in class, if you remember, we were able to pull up a multiplication chart, and we seen that these numbers that goes diagonal from top to bottom, that diagonal line which literally cuts the multiplication chart into two right triangles, we said that line is the square roots. And so numbers like 25, 49, 64, these numbers are called perfect squares. 100, 121, 144, these numbers are called 169. They're called perfect squares because they're non-negative or principal square roots of whole numbers. Now you have to remember, whole numbers are not integers. Integers are negative 5, whereas a whole number would be 5. Okay, numbers that are not perfect squares do not have whole number square roots. And you can use perfect squares to estimate these. This is something we definitely we're going to have to take a real in-depth look at to make sure that we understand how to estimate the root of a non-perfect square. Okay, so please write this information down if you would. Also, make sure you download and bring with you to class your multiplication table I want it from 1 to 30, and you should be fine. If you have any questions on this, please let me know. I am going to put something up that's talking about these particular non-perfect squares and how we estimate them. For example, as you can see here, we are looking for the square root of 64, and it's the principal square root. So again, we know that since 8 times 8 is 64, we can say that the principal square root of the non-negative square root of 64 is 8. And this one, the square root of 44, is going to be irrational. This is something that we need to know the term for. It is an irrational number, and we will be able to, just in a minute, evaluate what those are. So if you don't mind, please let me make sure. Yes, 1, 2, 3, 4, 5, and 6. So do those and bring them in and let me take a look. You might want to write 7, 8, 9, 10, 11, 12, 13, 14, 15 down. You might want to 16 and 17. So yeah, work these, and as I put the other video up to talk about how to find these irrational numbers, you might want to jot these down too. So go ahead and stop the video, do all the practice work, and of course, this practice work is what you bring in for extra credit. I'll see you soon.